Adam? I don't hear... Ah, there we go. Hey, can you hear me okay?
Yeah, I can hear you.
Hey, how are you?
I'm fine, you okay?
I am grand. Are you ready to begin?
Yeah.
Okay, let's see. Continue integration?
Yep.
Okay, definite integrals. What's this about? We'll see. We'll get there. You'll see. Let me see if I need to do anything else. Sure. There are 3 stages. Yeah. Okay. Okay, how do we do this one? If you're doing it just normal integration.
Okay. So would you expand the bracket first?
Yep.
Wait, so do you multiply it? Do you square everything in the bracket, or do you like expand the brackets?
Expand the bracket so it's like that bracket times itself.
Okay. Yeah. So to become 2 over 3 x to the power of 2 over 3.
Is that after integrating it?
No.
So it would just be x to the 2 over 3.
Yeah, because you add them together, the indices.
The index, yeah.
Okay.
Okay. What else?
And you get minus x to a third. Minus x to a third. And then you get, is it just 1?
Yeah.
Plus 1. Okay.
And might be easier to simplify if you know how.
Would that become minus 2x to a third?
Yes, well done. Okay, so now let's try integrating this.
Okay. Do you add 1 first, then multiply?
Add
Or
1
do you
and
multiply,
then
then add 1?
add 1, then divide.
Okay. Oh, divide, yeah, sorry.
Yeah.
Divide. So the answer be, after integrating it once, 3 over 5x to the power of 3 over 5.
5 over 3, I believe.
Is it 5 over 3? Then
So
I put it back.
yeah, so you did, yeah, first one's correct. 3 over 5, 5 over 3, yeah.
And then it would be minus 3 over 2x to the power of 4 over 3.
Let me see. Did you add to the 4 over 3? And what goes in the front?
Minus 3 over 2.
Looks good to me.
Plus c.
Plus, what is the integral of 1? What differentiator gives you 1?
Was it 0?
So the derivative of 1 is 0. The derivative of what gives you 1? Or what is the integral of 1?
But if you did the integral of 1, it'd be minus. I'll be minus.
It would be x.
X. Yeah.
The derivative of x is 1. Usually you would have a plus c at the end. However, with definite integration, which is what we have now, c will always be 0. We don't need to worry about it. So far so good. Just normal integration. What is this 1 and 0 about? So I'll kind of explain it in a second. Between 1 and 0, that means, and I put them in square brackets at this stage.
Yeah.
1 at the top, 0 there. Sub 1 for x, and then do your answer, subtract when x is 0, sub 0 for x.
Okay.
So we sub 1 for x, and then we take away what we get when we sub 0 for x. And we'll explain why in a second.
So I did the first part, it gave me 1/10, and then you do answer minus square bracket.
1.
1/10.
Are you sure? 3/5. So. Yeah, okay, but it's also plus 1 at the end, isn't it?
Yeah, I believe I put that.
Let me see this thing. 3/5 minus 3/2. Over 2. Yeah, you're all right. So that is 1/10 minus, any idea what this next bit is?
Would it just be 0?
Yep. And so final answer?
1/10.
1/10. Great. So that's what those numbers in the front mean. You integrate as normal, sub in the first one, sub in the second one, and first answer take away second. Yep. That's how you check your answer. Also kind of cheat. So this kind of difficult substitution at the end, what you do is you can just put it into your calculator. So this integral button under menu, well, you can see it. So bracket x to the third minus 1 squared. You go to this front in between 1 and 2. Let's see. Okay, so this is what an exam question looks like. Let me just see something for a second. Oh, they all look like this. Let me see. Let me see. Let me see. They all look like that. Let me see. And then they get a bit harder. Okay, I just want to take the most challenging of these. My guess, so that one, I think the best of these is this one. Yeah. Okay, let's try this one.
Okay.
Yeah, I think this is the best one.
So when you put it into the calculator, does it need to be 2x and then in brackets and then dx?
Well, yeah, not supposed to put it in the calculator. Just to check your answer, really. Let's see. And the reason why is so that I picked this one is because it thwarts you from doing that. I just literally copy and paste it in. So fraction first will help. Two on the top.
Well, I turned it to 2x to the power of minus a half.
That'll work.
Okay.
And you press right or left until you get into those other boxes.
Yeah.
Okay, so I'll do that. And so this is what I get. The problem is, the reason why I picked this question and they're kind of onto us is they wanted it in the form of a plus b root 3. Okay. So other questions will say put it as a fraction, and at the end you just press answer equals and it gives it as a fraction. In this case, the calculator doesn't know how to do that with a square root.
Yeah.
So it forces us to actually do it manually, although at the end we can press SD and check that the decimal of our fraction is the same as this decimal, and then we'll know we're correct.
Yeah. I put into the calculator, so when I integrated it, I got, so from 2x to the power of minus a half, I added 1 to minus a half, which gives you a half.
Yeah.
And then I divided that by 2, which gave you 4.
Yeah.
Which gives you 4x to the power of a half. And then I put into the calculator brackets for brackets 12, close brackets, to the power of a half, close brackets, and then minus brackets 4, close brackets, to the power of a half, close brackets.
You're right.
But I got 5.85 or 5.86.
Let's try putting them in manually. Separately.
Separately, okay.
What is the first one?
Okay. The first one is 13.86.
Okay. What is to the power of a half the same as?
To the power, well, it's root 2. Well, no, root x.
Yeah, square root. So try 4 root 12. Let's see what it says.
So it would be 4 brackets root 12.
Yeah. Or just 4 root 12, whichever, yeah.
And then to the power of... Oh, no, not to the power of.
Yeah.
8 root 3.
Okay, so we have to actually put it as square root. So that's 8 root 3. And same thing for this one.
Okay. 8. So would it be 8 plus 8 root 3?
Yeah, minus 8 plus 8 root 3.
Okay.
Minus 8 plus 8 root 3. Put that in your calculator. See what it says.
Okay. 5.85.
Yeah. Okay. Great. Minus 8 plus 8 root 3. Minus 8 plus 8 root 3. So we were supposed to do a bit more. We were supposed to do the square root of 12. And we were supposed to say that's the same as the square root of 4 times the square root of 3. The square root of 4 is 2. And so 2 root 3.
Yeah.
4 times 2 is 8. But actually, so long as we put it as a square root, the calculator can take over. But not to the power of a half, even though they're the same thing. Okay, so we can do a bit with the calculator, but we get the idea. So that stops us from just using the calculator completely. And let me just show you. So this is the type of thing they say these days: use calculus. Yeah. And that's to stop you. from doing it any other way. I think you're alright. Show that this one, I think it's okay. Okay, and then this one, yeah, is a good one.
Okay. So I got to the point where I've integrated 9 root x.
Uh-huh.
I got 6x to the power of 3 root 2.
So that is 6x to the 3/2?
Yeah.
Okay. In between k and 4.
Okay. So can we substitute 4 for x first and work all those out?
Yeah, if you want.
Okay. I got 48.
For the when you sub in 4?
Yeah.
Okay. So that's the second one.
Mhm.
And then how about the first one with the k?
It will be 6k.
So that will be 6k to the 3/2. And we're trying to solve for k. What do we do with this?
We make it equal to 702 first.
Well done.
And then can we add 48 to both sides?
Yep.
750.
Mm-hmm.
And then we can divide by 6 on both sides.
Yep.
Which is 125.
Okay.
And then can we root it by 3/2?
You should root it and then, let me see. No. Sorry, what's next?
Could you root it by 3/2?
If you know how to do that.
Okay. Is it 25?
Well done. So you cube root it, you get 5, so it's like 5 squared. So k is 25. Great. And I'll just, shouldn't show you this one, but sure anyway. 9 root x. 9 root x. Press right. Between 4 and I can only use x. So I'm using x up in that thing there.
Yeah.
Press right again. Alpha equals 702. Shift, solve, lucky 7. Roll the dice. There we got it. 25. Okay, but I'm sure they'll come up with some way to stop us doing that.
Yeah.
25. So this one's very similar. Is it worth doing a similar one, or you think you're okay for these?
I think I should be okay for this.
Okay, I think you get the idea. Here the unknown is in a different spot.
Okay.
Yeah, alright. It's not easy to integrate either, I think.
So I integrated it and I got a over brackets 3 over 2 close brackets and then x to the power of 3 over 2.
All right. What is a divided by 3 over 2?
1.5, so it'd be a over 1.5.
Yep. What is
Oh, it'd be 3 over 2a. Or would that be right?
how do you divide fractions? What
Keep
is
change split.
Yep.
What? So you keep and then multiply, then flip it.
Yep.
So it'd be a times 2 over 3.
Yep.
Which gives you 2 over 3a.
Yeah. So that's 2/3 a x to the 3 over 2. Yeah. And it's quite common when you're integrating that the fraction flips like that.
Yeah.
Let me see. So that was a half, 3 over 2. Okay. What is next?
Okay.
Yeah, this will work out.
And then you substitute 9 in for x.
Yep.
Okay. Well, I did 9 to the power of 3 over 2, I got 27.
Okay.
And then could you use 2 over 3 or not? Because is that one integer, a and 2 over 3?
Yeah, that's all one thing.
Okay.
And for the purposes of your calculator, you can let a be 1 and just remember to put it back in at the end.
Okay. So could you just do 2 over 3 times 27?
Yep.
Times, which is 18.
Mm-hmm.
Would it be 18a?
Well done.
Okay. For 4, I got 16 over 3a.
Yeah, that's what I was expecting.
And then we make them both equal to minus 114.
Yeah. And what's in between the two of them?
Minus.
Well done.
Oh, so we just do 18 minus. So 38 over 3a equals minus 114. And then you can times by 3 on both sides.
Mm-hmm.
Minus 342 on the right.
Okay.
And then you can divide by 38 on both sides.
Yep.
Which gives you minus 9. So a is equal to minus 9.
Great. That's good. Minus 9. And yes, this one you cannot solve with the calculator because the a is like the x and that is actually in with the other x, so it's treated that way. But I'm happy. This is why. So the initial ones are essentially equal to x and you have to solve for x.
Yeah.
Then we did one where the unknown is in the integral.
Yeah.
Now we did one where the unknown is in the expression. And so I think that counts as one of each. I'm happy. Okay. No, making a command decision. It'll be fine. Can you hear me? Curve. Hi, can you hear me? Hello? Adam?
Hi, it's back.
Okay, I'll try just audio only. Maybe it takes less internet bandwidth or whatever. Okay, command decision. You're fine for that previous stuff. I'm not doing. There's a little. I'll take a look. There's a little thing at the end where it's a quadratic, but it's the same basic thing. It's just it'll just be a quadratic at the end. You'll make it equal to 0. Yeah. Okay, so what is that definite integration stuff about? It allows you to find the area under a curve, which is good for different stuff, like the area under a line on a velocity time graph gives you the displacement, different stuff.
Yeah.
You can prove it, and it's fascinating stuff, and that can be your independent assignment. I'm not doing that. That's not a good use of our time. Basically, if you were to, so you see this curve down here.
Yeah.
If you did the integral of this function, f of x, whatever that is, x cubed minus 7x squared, all the stuff.
Yeah.
If you integrate that, you sub in b, that would be from b to 0.
Yeah.
Then you take away what you get when you sub in a, that would be from a to 0, and you end up getting just the shaded part. So total area minus unshaded equals shaded.
So including the one on the right as well, the unshaded.
Yeah. So this one on the right now. If we do b minus a, then that is from b to 0 minus from a to 0.
Could you do a to minus b, or would that not work?
A minus b, I think, would give you the negative. It would give you a negative number.
Okay.
So if this area is 20, that would give you a minus 20, something like that.
Okay.
Okay, let's try this one. Ooh, there's a little something to this. How do we do this one?
Looks like a quadratic.
Yep.
Is that going to solve as a quadratic?
Good thinking.
Okay. It would be 1x squared. Wait, no, minus. Would it be minus?
Yep, minus 1.
Okay, minus 1. And then minus 1x. And then 20.
Mm-hmm.
So x is 4 and x is minus 5.
Okay.
So would b be 4?
Yes. So this is roughly what the curve looks like. And so they want the area of the finite region between the curve and the x-axis. Okay. So what are we integrating between?
4 and minus 5.
Yep.
So would it be 4 on the top and minus 5 on the bottom? Yeah.
Yep.
So what would the equation be? 20 minus x squared.
Yep.
Okay. Should I solve it manually, or can I just put it into the calculator?
I'll let you put it in the calculator.
Okay.
You've earned it.
Okay. I got 121.5.
Sounds good to me. Would you believe I said 121.5? Yeah.
Yeah.
I said to the head of maths, every student didn't have one of these calculators, so they couldn't integrate.
Wow.
And I said, like, next year, like, tell them if they don't have a calculator, they're not coming on the course. And we'll let them on, but we'll just figure it out, but at least they'll buy a calculator or something.
Yeah.
No, he wouldn't do it. It's just handed
Wait,
to you.
so for that question, do you have to show you're working, or can you just put it into the calculator?
You better show you're working. But
Okay.
the way you show you're working, yeah, you would have to integrate it.
Yeah.
So the working out looks like this. So 20x minus a half x squared minus a third x cubed. In between 4 and minus 5 square brackets. These that were on the left are now on the right.
Yeah.
Wherever there was an x, replace it with a 4. And so the actual work is the integrating.
Yeah.
This part is just replacing.
So you don't have to show the substitution of x.
No.
Okay.
Because in theory, you could just put that whole thing into your calculator exactly as it's written.
Yeah.
So you could show this if back in the old days, and especially when we didn't have the calculator, I would recommend that they do this half first and then minus and then this half second.
Yeah.
But all in one go. And in fact, I even don't recommend that you put this in your calculator. I recommend that you just go back to the original and put that in the calculator.
Yeah.
Because it should give you the same answer, and you know that first one will be correct.
Yeah.
Okay, let's see what this one is. The coordinates of A and B, the exact region. Let's see what this one is. How would you start this one?
Did you expand the brackets first?
There is actually a quick way. What do you know about the y coordinate at P and Q?
0.
And y is equal to the h of x, and so the h of x is 0. So would you know how to solve that without expanding it? It's actually very easy.
You solve as a quadratic.
Either. So something times something gives you 0.
Yeah.
What times what? Pick any examples.
0 times 0.
Yeah, basically at least one of them has to be 0.
Yeah.
Either minus x minus 1 squared equals 0 or x minus 4 equals 0. And then you can just solve them separately. What would be the second one?
X equals 4.
And so that one is 4. And so then this one?
That'd be 0.
Nope. What value of x will make it 0?
Oh. 1.
Yeah, or you could do it long way, like divide both sides by minus 1, square root both sides. You end up with x minus 1 is 0.
Yeah.
And so x is 1. And so that is 1. And then you just integrate that between 1 and 4.
Yeah.
I'm not worried. Let me see this one. Let me see. All right. The coordinates of A.
Okay. So you can't solve this one as a quadratic, can you? You have to integrate.
Well, you have to solve it somehow. So it'll be 0 equals. How else can you write
X to the power of a half.
so
Or 8x to the power of a half, sorry.
minus x squared? Any idea how you'd solve this one? Here's what I'm thinking. The smaller one.
Yeah.
Let x to the half be equal to a. Something like that.
Okay.
So what would the first part become?
A minus x squared.
8a.
8a, yeah.
Minus, okay, x squared is equal to x to the half to the what?
4.
Very good. And so, this one?
Minus x to the half to the 4.
And what is x to the half? The same as?
Oh, it's a. So
So
it'd be x to the a to the 4.
just a to the 4.
Okay.
We replaced it. And so that can be calculated. Let's see. Quite unusual. Per 4. So minus 1 is that x cubed is 0. X squared is 0. X to the 1 is 8. And then the other one is 0. So what will this one be?
I got x is 1 and just x is 1.
I shouldn't. Is your input different from mine?
I put in minus 1x to the power of 4 and then 0, 0, 8x plus 0. I got x to the is 2.
Yes. X is 2, x is 0, and then 2 imaginary numbers, I think.
Yeah.
And so A is, what's the coordinates of A?
A is 2.
So 2, 0.
Yeah.
And then you just go from there. Let me see. Yes, the smaller one, you can let be equal to some dummy variable.
Okay.
And then you solve, oh no, that's wrong. It's not, we're not finished. X isn't 2, A is 2. A is 2. And now we just created A. So now we have to like uncreate it. We have to send it.
How is a 2?
So for this
If
equation,
it was a times 2, it would be 16. 8 times 2 would be 16.
yeah, that's 16. And what is 2 to the power of 4?
16.
Yeah, so 16 minus 16 is 0.
Oh, yeah.
So we solved that one, but we just created it. So now we have to undo it. So x to the half is 2. And so what is x? We have to solve for x.
Okay. It'll be 1.
The opposite. That's like square root of x is 2. So what's the opposite of square root?
Squared.
Yeah.
Wait, so would you square 2 by a half?
You square both sides.
Okay.
And so
We 1. 2 to the... Wait, you square 2, so it'd be 4.
yeah. And so a is 4, 0. This question's crazy. I need to check the exam questions. Check. Oh, I'm spending hours checking these exam questions.
Yeah.
See, these are, it's because the spec changed. I say exam questions, like these are the best representation of the questions. But I just want to make sure, just get the sense that they're not going to do it like that. 4, 0, the rest of that is normal. So this was this to the half type. Okay. Yeah, I'm not seeing any others of that. I think we'll be fine. Right, this one Yeah, is a working in reverse type. Hang on, before I do this. The curve, me, find the coordinates. Yeah. It's alright. Yeah, so the only one worth doing is this one. Okay, let's try this one.
So can we solve y as the quadratic?
I don't think so. The shaded region is bound by the curve. So it's basically you would, to get that area, you would integrate between what and what?
0 and k.
So k and 0. And so that's 6x squared minus 12x plus 9 with respect to x.
Equals 27.
Very good.
And now can we integrate?
Yeah. You confident with this one?
Yeah.
I want to see. So I'm going to try putting the whole thing in a calculator.
Okay.
Give it a go. Use x instead of k.
Okay.
Because it's good to be able to check the answer.
Well, let me equal it to 27. Oh, no, it can't. It's fine. It's fine. I got x is 3.
Yep. X is 3. And I'm sure if you did that the long way and you got 2x cubed and minus 6x squared plus 9x, you sub in k, then you sub in 0, you'll get a quadratic. One answer will be 0, the other will be 3. And the rest are very, very similar. So the only difference is this one, for this one you'd expand the brackets first, I think. And then, it's not difficult. Those ones.
Probably between a tick and a half.
So they're all right. Let's see. Area under the x-axis. What's this about? I'll just show a quick illustration. Man, I used to work far too hard. I used to show all this stuff. It's just not a good use of your time. Hang on. Let me do this better. Oh, it's all the same. Something like that. Yeah, I'm going to even do it easier. That's 3. That's 2. Minus 2. What's the area of the top rectangle?
Would it just be 2 times 3?
Yep.
6.
What's the area of the bottom rectangle?
Minus 6.
So calculator will say minus 6. What is it actually?
6.
Yeah. So if your calculator gives you an area of minus 6 or something like that, you just have to know that actually that area is minus 6.
Yeah.
A little trick is if you integrated this, calculator would say the area is 0 because it would do 6 plus minus 6. So you'd get an area of 0. So you'd have to separate them out. Do the plus bits, do the minus bits, and then just and add them together. All right, what is this example 10?
So can we multiply x by everything in the bracket?
Yeah.
X squared minus 3x.
X squared minus 3x. Okay.
And then we integrate.
Yeah.
Which would be 1/3 x to the power of 3. Other one would just be minus 3.
You're thinking of differentiation?
Oh. So it'd be plus 1. So it'd be power of 2, and then you divide it minus 3 over 2 to the power of 2. Yeah.
That's it. Let's see. Where would that cut the... So that is going to look like that. And so where does it... Between what and what are we integrating?
Between 0 and... y.
So you'd have to solve this one.
So we solve x squared minus 3x as a quadratic.
Yeah.
Okay. I got x is 1. So it's between... No, 3, sorry.
Yeah.
So between 3 and 0. So it'd be... Yeah. And then you sub in 3 for x.
Yep. What do you get there? Oh, and you can do the whole thing in calculator if you want.
Okay.
Actually, my graph isn't the best.
So I got for the first half minus 9 over 2.
Okay.
And then you take it away from 0.
Yeah. What do you get?
Which gives you minus 9 over 2.
And so what is the area?
Wait, would it just be minus 9 over 2 then?
Calculator says it's minus 9 over 2. What did I tell you would happen? Where is it?
Oh, it would be positive 9 over 2, wouldn't it?
Yeah. So minus 9 over 2, and therefore it'll be just 9 over 2. 4.5 square units. Whatever. And there we go. So because it's under the line, it gives it as that one. They have 4.5. I'll use 4.5. There we go. And so you just have to know, obviously it's an area. And so it's going to be that one.
Yeah.
So these two, like with the two at the start, you have to do them separately. Otherwise they kind of end up giving you 0.
Okay.
Let's see this one. Okay. Sketch the curve and find the area. So sketch this curve. What will she look like?
Okay. So would it be x squared minus 1x?
You love expanding brackets. Alright. X squared minus x.
And then would the other one just be x plus 3?
Mm-hmm.
Yeah. And then do you multiply the two brackets together, or does that not work?
Yeah, it will work actually.
Okay. I got x cubed plus 3x squared minus x squared minus 3x, which simplifies to x cubed plus is it just 3x? Would it be 2x squared?
Let me see. Plus.
So if it was 3x squared minus x squared, would that be 2x squared?
Minus 3x. So x cubed minus x squared, is it?
No, it was 3x squared minus x squared.
Yeah, you're right. So it'll be 2x squared.
Okay. So it'll be x cubed plus 2x squared minus 3x.
Yeah.
And then we can integrate.
Hold your horses. Where does it cut the x-axis? So we need to sketch it first.
We need the solve as a cubic quadratic.
Cubic, yeah.
I got x is 1.
Yeah.
And x is minus 3.
Should be one more. Cubic.
And x is 0.
There you go. What is... so we have x cubed. What will that look like? If you sketch that correctly.
I got from bottom left up and then down through 0 and then back up again.
Adam, you're very good. So that goes like that. You're right.
Yep.
Okay. And so you wanted to integrate. Okay.
Okay. So it become a quarter x to the power of 4 plus 2 over 3 x cubed minus 3 over 2 x squared.
That's it. Okay, so how do we get the region? The finite area, the finite region.
So we put okay, so we need two different, like, you know, when you substitute numbers in, you need to do like 1 and 0 and then 0 and 3, minus 3.
Well done.
And then do you add them together or take them away at the end?
You would just change the -1 to plus.
Okay. So there's two answers.
Yeah, so you do the 1 and 0 one. Which one will give you the negative answer?
The one on the left.
This one over here?
Yeah.
That's above the line.
Oh, so it'd be the one on the right then.
Yeah, between 1 and 0.
Okay. So I got minus 7 over 12 on the right, or just 7 over 12.
Okay, there's nothing wrong with that. So it's equal to minus 7 over 12. So that's 7 over 12. And then the one on the left.
Okay. So would it be 0 at the top and minus 3 at the bottom?
Yeah.
Okay. And for the other one, I got 45 over 4. It used to be minus 45 over 4, then you minus it from 0. Well, 0 minus that, which gives you 45 over 4.
Oh, I have a bad feeling about this. That should have been a positive because it was above the line. Alright, so put these two together. What do you get?
.71 over 6. I think.
71 over 6. Nailed it.
Yep.
Okay, let's see this one. Same idea. Fine. This one just has one region, so you can just make it positive at the end.
Yep.
One region, make it positive. Here you have a mix of regions, so you have to do them separately.
Yeah.
Let me see. Fine. That one.
Probably a tick. It was pretty easy.
Yes, we got so much done. So then they'll get trickier.
Okay.
This is a proper one. And then, yay. So that will be the end of one more section, and then we're finished this chapter. That's great.
Yep.
Yeah, how was that for you?
That was great.
And your mum said you did a mock, was it?
Yeah.
And was it just the pure paper?
Yeah. It was AS paper 1.
That's great. Okay. Any questions in general?
No.
All right. Well done, Adam. You did great.
Thank you.
And I look forward to talking to you again next time.
You too. Bye.
Cheers. Take care. Bye bye.